Good day to our lecturer, Professor Dr. Burhan. So today, me and my teammates are going to present about our group project, which is AI-based plant disease detection system. Okay, so as introduction of our team, myself, Melvin Devan, is the project manager, and then Hari Ganesh is our AI engineer. Enoch Nirmal is our treasurer. Ishwarnath is the secretary, and also Tavanesh is our marketing. So for the introduction, the AI-based plant disease detection system is an innovative web application that uses a trained convolutional neural network to automatically identify disease from images of plant leaves. Designed for practical use in agriculture, it supports 5 essential crops: tomato, potato, apple, grape, and corn, and can accurately classify 25 different disease types. By providing fast, accessible, and reliable diagnosis, this tool empowers farmers and growers to take timely action, protect crop health, and support sustainable farming practices. So, for the objective, we have our main objective, which is to develop an AI-based plant disease detection system, and also to detect plant disease using leaf images. So, to get this main objective, we provide the confidence score and also the treatment recommendation. And also we store diagnosis history, and finally the user can generate downloadable PDF reports, and also they can see their monitoring features through the admin portal.
Okay, so the next will be problem statement. So now the current challenges I'm looking for is the first one is lack of agricultural experts in rural areas. Second challenge is delayed disease detection leads to like crop damage or reduced productivity. The third problem would be manual diagnosis is error prone, and the last one would be existing AI system like so only focus on prediction and somehow it do not provide treatment or history tracking. Next, so next I will be present on the case study. So the case study that we refer to the system is the Plantix, which is commercial plant disease detection system. So Plantix is a real and widely used commercial mobile application developed to help farmers identify plant diseases using image recognition technology. The system allows users to capture photos of infected plant leaves and receive disease identification along with general treatment advice. While Plantix has been successfully adopted in the agricultural market and demonstrates the practical use of AI in farming, it is primarily designed for general diagnosis and advisory purposes. The system does not emphasize transparency of AI predictions, detailed historical tracking, or system level management features. So, as a result, users receive disease information but have limited insight into prediction confidence, personalized treatment tracking, or downloadable reports for monitoring plant health over time. So, the limitations compared to our system would be such as provides disease identification but does not display a clear confidence level for AI prediction. The second limitation would be lacks a structured diagnosis history that allows users to track previous scans over time. The third limitation would be does not generate downloadable PDF reports for record keeping or analysis. The fourth one would be treatment recommendations are mostly general and not structured by system defined models. And the fifth one would be no admin dashboard to monitor usage, disease trends, or user activity. The next limitation would be limited transparency in explaining how AI decisions are made. And the last limitation compared to our system is designed mainly as a mobile advisory app, not as a fully managed AI system. So next.
I would like to talk about the work breakdown structure. The work breakdown structure was developed to systematically decompose the AI plant-based system into hierarchical, manageable components, ensuring comprehensive project planning and control. The VBS organizes the entire project lifecycle into 6 sequential, logical structured phases, each containing specific deliverables and assigned responsibility. So for the phase 1 is problem and requirements. We identify the main disease affecting 5 key crops and define what the system needs to do. Scan, leaves, diagnose disease and suggest treatments. For phase 2, data collection and prep. Gather thousands of leaf images, clean them up and split them into training and testing sets for the AI model. Phase 3, model development. Build and train a CNN model to recognize diseases, targeting over 95% accuracy through evaluation and tuning. For phase 4, system build. Created the web app, user login, image upload and real-time scanning treatment, suggestion and PDF report generation. For phase 5, testing and validation. Tested each feature with real images, validated treatment accuracy and fixed bugs to ensure reliability. For phase 6, deployment and monitoring. Launched the system on a live server, set up performance tracking and created an admin dashboard for ongoing maintenance. So this is the main points for work breakdown structure. So for the next slide. So this is for time management graph. Time management was strategically handled through the systematic development of a comprehensive project schedule and detailed Gantt chart. The time management framework was designed to coordinate the complex, independent activities of AI development and software engineering within a constrained academic timeline. The project timeline was constructed using two-tier approach. First, a high-level Gantt chart template was adapted to specific requirements for the AI-based plant disease detection system, breaking the project into 14 distinct tasks spanning from December 2025 to January 2026. Second, this timeline was integrated with a more detailed work breakdown structure that specified day-by-day activities across 6 project phases. So that's all from me.
Okay, hello everyone. So in this, we're gonna look at the net present value. So also known as NVP, which is a core metric used in the financial analysis to determine the profitable of investment of a project. By definition, NPV is a difference between a present value cash flow and the present value of cash outflow over a specific period of time. Essentially, it tells us if the return from a project exceed the cost of capitals. A simple rule of thumb: the higher the NPV, the better the investment. So in this we can result have we calculate the present value for each year. We can see how the value future money decrease over time due to discount rate. For example, let's say for 30,000 plan for 2021, it's only worth 27,272.73 in today's term. In total, this value are subtracting the initial investment. Our final NPV result is 195,664.49. Because this NPV is positive, and it is indicate the project is expected to generate value well above the cost of the initial investment. Next. So next we're gonna go in deeper in our projects. So first, the system flow of our project is when we start the website, the user has to register and log into a system, and then user have to upload the plant leaf images they want, which image they want. And the third is the image will, after the upload the image will process by resizing and normalizing behind the back end. And then the next step will go for the NNP model, perform a disease classification So which is means the model that we are trained will perform our classification whether it's like um is have affected or not. And the fifth one, you will output the confidence score. It's a confidence score which will be calculated, and the next one is the result are display and store in the database. And lastly, user may generate in a PDF form report. Then next. So the next one is a project implementation. So the AI-based plant disease detection system is a web-based application that provides real-time plant disease diagnosis using artificial intelligence. The system is developed using Python and Flask as a backend and integrate with CNN for image-based disease classifications. And user must log in into access the system upload and plant disease images. Once is images, you use like OpenCV and use the model that we have trained to classify it. Once it classify it, it will came out with a confidence level. Then we know whether it's like affected or if it is healthy or what. And then the system also will display a treatment recommendation that are suitable for the plants that affected, and all the diagnosis result will be stored in the database where the user or admin can view all the diagnosis history. The system also support like 25 disease classes, achieving over 90% training accuracy and approximately 89% validation accuracy. Next.
Okay, so next we will move on to the demonstration part. So as you guys can see, this is our system. So as we entered our system, there will be a main page which includes what we have in our system. So a small intro for plant disease. So why we need to do early detection methods, key features, and our supported crops in the system. So once we enter to the system, there will be a main page including scan leaf option. So here we can, once we choose the scan leaf option, there will be an option where we can choose the file. So here, for example, if we choose, there will be a lot of options. For example, here I'm going to choose an image of apple black rod, and once I click the scan button, and it will appear the result for apple black rod. The confidence level is 99%, and once the disease has been detected, we can view the treatment recommendation. So these are the treatment recommendation, including with the cause, and the treatment has been recommended, the fertilizers that has been recommended, and the medicines for the plants. And here we can also save the PDF as the PDF report, and we can also view it. Okay, now let's move on to the admin page. So in the admin page, the admin can see the total number of users that are using the system and total scans. And the admin can also see the analysis for top 5 diseases, scans per month, users registered per month, top active 5 users, and disease category breakdown, detection accuracy over time, and most affected plant species. Other than that, the admin can also view the scan history. For example, this one just now I have scanned this, and it is also stored in the scan histories. So that's all for the system, and let's move on to the slide. So the conclusion is the AI-based plant disease detection system demonstrates how artificial intelligence can be effectively applied to solve real-world agriculture problems. By utilizing image processing and machine learning techniques, the system is able to accurately detect plant diseases and provide useful treatment recommendations through a web-based platform. The project was successfully developed and completed by a group of 5 members as part of the AI project management subject, highlighting effective teamwork, planning, and collaboration in managing and delivering an AI-based system. So the Q&A session is, the question is, how does the system perform in real-world condition with imperfect images, for example, blurry, bad lighting, and police?
Okay, so the answers would be like we pre-process images to normalize lighting and enhance contrast. So the model is trained on augmented data that includes realistic variations. However, for best results, we guide users through simple upload guidelines like clear leaf focus, good lighting, single leaf per image. So for future versions may include multi-leaf detection and more robust pre-processing. Yes, that's all. So that's all
So
from
that's
us.
all from us.
You.
Thank you.
Thank you.